Welcome you all. In this lecture, we will discuss about the multi-layer neural network for multi-class problems. In earlier classes, we have discussed about the regression and binary classification. So here in regression, we have to predict the future values depending on available data. And in the binary classification, whether we have to say the output is yes or no or true or false like this. If example, if I am taking, we have a data set which consisting of our weight and height. Let us take 150 centimeters height and some 70 kgs is the weight, then this person is facing obesity problem or not, it can be uh, get by this using binary classification. In this class we are going to discuss about the multi-class problems. Example, we have a two or three features and which are belongs to the different classes. These are classes more than one. Example, whether it is a uh, dog or cat or rat like this, there are different this depending on the input features we have to classify into these one of the categories. Okay, here we have to use a multi-class problems. So in this example I have taken which one, a smart vending machine is designed to dispense three types of beverages based on the two inputs. Okay, here we are taking the two inputs, one is the temperature and another one is the time of the day. So the time of the day we are taking entire 24 hours and three classes we are going to classify, that is according to the beverages, that is hot coffee, cold juice and energy drink. So here the hot coffee means when temperature and time is in the morning times and temperature is very low, then we are offer the hot coffee. And during the summer in the afternoon we are offering cold juice, that is based on the 25 degrees of centimeter centigrade and 12 after afternoon 12 o'clock, then we are offering cold juice. And at night time the temperature is 20 and then we are offering energy drink. According to we have to classify on for the upcoming data based on this past available data. So now we are going to train our multi-layer neural network based on this data. So here I first sample I am taking 5 comma 8, that is temperature is 5 and your time is 8, and these are the weights. Okay, the weights randomly I have taken. So W11 and W12, W21, W22 and WO1, WO2 like this. All the weights and biases I have taken over here. Then we are calculating the first, the input received at H1 is the, it is multiplied by the zero point 0.2 multiplied with 5 and zero point 0.4 multiplied with the 8 plus bias. So I am getting Z1 equal to 4.3 and Z2 equal to minus 0.9. Immediately we have to take the decision on this incoming data. So we are applying the ReLU function. So ReLU function, all of you know that, that is if this output is greater than 0, then the corresponding value we have to consider. If it is less than 0, then answer to become 0. So in case of Z1, our answer is 4.3. But in case of Z2, that is H2 is a, because less than 0, that is minus 0.9. So we have our output is 0. Now after obtaining this H1 and H2, we are going to calculate the Y1, Y2, Y3. The same way we have to make the sum up again, that is Z3 over here. So Z3 is the H1 into 0.3 plus H2 into minus 0.2, and we have received 1.49, and Z4 we have obtained 0.33, and Z5 we have obtained 2.02. Okay, these are the summation. So why before taking the decision across the output nodes, but which type of decision we have to consider over here. In case of binary classification we have taken binary classification we have taken sigmoid activation function. That formula is the 1 by 1 plus e to the power of minus x or minus z. So here the softmax is the range is from 0 to 1, and at the origin it is 0. So greater than 0.5 we are considering it as a 1, and less than 0.5 we are considering it as a 0. Okay, here this is especially used for the binary classification, but here we have a multi-class problems because more than one classes were there. So this sigmoid function may not work over here. That's why we need to take another activation function that is called as a softmax activation function. Here softmax activation function will give you the percentage of uh, importance, that is importance to the neurons, which neuron got more percentage or more related to the output side. So that can be obtained by the softmax. Here the formula is e to the power of z3, that is e to the power of whichever if we are calculating the output across this neuron, then we can take e to the power of z3 by total outputs of the this z3, z4 and z5. Similarly, if I want to calculate at this one, then e to the power of z4 by this after substituting this one z3 and z4 z5 already we have obtained. If I'm doing like this, then I'm getting the 0.33 and y4 e to the power of z4 by same denominator is common for all the I have this y1 and y2, y3, y4 and y5. So here I got 0.10 followed by y5 we have got 0.56. So if I'm converted into the percentages over here, then 33 percentage obtained by y3, 10 percentage obtained by y4 and 56 obtained by y5. But actually, if I'm coming to the problem, what we have to get is the temperature is 5 and time is 8. Our class is the hot coffee. But what we have obtained, this third one is the your energy drink. So this is incorrect answer. Okay. So where we did the mistake means we have taken the weights and biases are initially random values. Okay. And these weights and biases are need to updated to reduce the loss function. So first we have to find the loss of this problem. The loss is we are taking as a binary cross entropy. Okay. Here I have taken Ti into log of yi cap. Ti is the targeted out. Ti is the targeted output and the target output right now we have to obtain the class 1 and but obtained we have class 3. So that after calculating this one we got 0.48. Next one the loss is 0.48 means we have to reduce this loss. So how we can reduce this class loss we have discussed in the last lectures by using the back propagation. So we need to update the all the weights and all the biases. Here I have taken one output layer weight and output layer bias. So that is dou L by dou W1, dou L by dou, this can be modified to dou L by dou Z3 and dou Z3 by dou WO1. So here how I have written, so please follow the last lectures. So this after the dou L by dou Z3 directly we can write as y cap minus T3. We can see over here the answer will come finally y cap minus T3. Okay, that is a targeted third one. And in the same way, dou L by dou B3 means dou L by dou Z3 into dou Z3 by dou P3. And hidden layer is the we have to update the each input weight according to the loss we have obtained at the output side. So dou L by dou W11 equal to dou L by dou Z3 and dou Z3 by dou H1, dou H by dou Z1 and dou Z1 by dou W11. If I am cancel all the terms, then RHS equal to LHS. Likewise, if I am updating the this bias at input side, dou L by dou B1, that is dou L by dou Z3, dou Z3 by dou H1 and dou H1 dou Z1 by dou B1. So this one if I am substituting all the values, then we will get like this. Then updated the already we know that updating weight formula W nu equal to W old minus alpha into dou L by dou Z, dou W. Updated bias is a B nu equal to B old minus alpha into dou L by dou P. So these are the updating equation. Means for this procedure is continue for the all the biases and weights after updating. Again we have to apply this method and check whether the loss is getting reduced or not. If it is not reduced to 0, again we have to repeat until the loss become 0 or almost negligible. So that is the procedure to find the multi-class problems. So here number of classes depending on the application as well as number of input neurons also depending on the how many input features they are providing. Here we have taken only 2 features. Some applications have a n number of features and n number of output classes. And this one also in the hidden layer, for simplicity, I have taken only 2 neurons, but sometimes it has been 4, 8, 10. If I am taking more hidden layer, that hidden layer neurons, then we can close to the better output. Okay. If you like the video, please click on the like button. Thank you.